Okay, hello everyone. My name is Vikram Madan. I lead product for SageMaker Ground Truth. And today we are going to talk about labeling 3D point cloud data with SageMaker Ground Truth for building your machine learning training data sets. So let's dive right in and let's start with an introduction of SageMaker Ground Truth. What SageMaker Ground Truth is essentially a service that helps you easily label training data for machine learning at scale. And basically, you will be able to create labeling jobs where you point to data that is in your S3 and you define a labeling task and you specify a set of labelers. And we'll discuss this further down the line. But you have multiple choices for which labelers that you choose. You can choose your own workers, you can use one of our third-party vendors, etc. Right? And when that labeling job starts, basically it is presenting the labeling task to those labelers, and the labeling task UI, where the labeling is actually performed, has many assistive labeling capabilities. And we'll discuss assistive labeling in depth later down the line. But the output of what is known as a labeling job is an accurately labeled training data set, which you can use to then train your machine learning model. And that training data set and those labels that were generated through the labeling job will all be dropped back into your S3. So moving on, let's talk about 3D point clouds and what they are. So you can think of 3D point clouds as essentially a 3D snapshot of a physical scene, basically a 3D image. And the 3D point cloud essentially encompasses a series of points with XY coordinates, XYZ coordinates that are rendered in a 3D space. Now, how do you generate a 3D point cloud? Typically, many customers use what is known as a LiDAR sensor or a light detection and ranging sensor. And this is almost can be seen as a video camera for 3D in the sense that it can continuously capture point-in-time snapshots of a physical environment. And LiDAR devices, for example, are mounted on, say, an autonomous vehicle, and that LiDAR device is then continuously capturing point-in-time snapshots of the surrounding physical scene around that autonomous vehicle. And when we think about these point-in-time snapshots, it's important to differentiate between a frame and a sequence, right? So a frame is a single point-in-time snapshot, whereas a sequence represents a period of time. So it's a sequence of frames that has been taken over a period of time. And on the right-hand side here, you basically see an image that demonstrates what a 3D point cloud looks like, right? So you can see the depth perception, and you can see how the points display, say, vehicles in a scene. So moving on, let's talk about what Ground Truth provides for 3D point clouds. So this is a cool new feature. So Ground Truth historically has supported image data, video data, and text data. So we added support for 3D point cloud data. And this was just last week. And specifically, we added support for 3 built-in use cases. And the first use case of the 3 is object detection. And this is essentially where you are looking at one point in time frame and you are identifying objects in the 3D space. And how you identify objects is you draw a 3D cuboid around those objects, so which is essentially a 3D box, right? So that gives you the location of that object, and it also classifies that object. Is that object a car, or is it a pedestrian, etc. The next use case is object tracking. And with object tracking, basically, you are tracking how an object moves across a sequence of 3D frames, right? You can see object detection was for one frame, object tracking is for a sequence of 3D frames. And you're actually tracking that same object, say that same pedestrian, across the series of frames, right? And you similarly do that by drawing that 3D box around the pedestrian, but you also ensure that that same pedestrian is marked with the same tracking ID across that sequence of frames. And the third use case, again, is specific for a single 3D frame. And in this use case, you're specifically segmenting the points in the point cloud, and you are essentially associating those with predefined categories. So you're going to say, of all these points in the point cloud, these are associated with vehicles, and these points are associated with road, and these points are associated with pedestrians, etc. Right? So those are the three use cases that we've added support for, and it's important to call out that these are built-in labeling tasks that we support. So we provide a UI that allows the labeler to perform that labeling task, right? And in addition, as we'll discuss later, we provide a number of assistive labeling capabilities in that UI that make labeling much easier for the labeler. So moving on, let's talk about a little bit about how do you develop data labeling pipelines with Ground Truth. So the support for 3D point clouds is an extension of our existing platform. So a lot of what I described in this slide basically already exists today with SageMaker Ground Truth. When we think about building data labeling pipelines, it all starts with the atomic unit of a labeling job. And what is a labeling job? And we discussed this in the initial slide earlier, but at a high level, a labeling job has three components, or three subcomponents, essentially, right? The first is what is being labeled, right? And that is the input data set, and that's living in S3, right? The second bit is what labeling, what is the labeling workflow? Like, what is the labeling task? And this is essentially how that data in S3 is being labeled, right? And then the third component here is who is doing the labeling, right? Who are the workers that are actually performing the labeling? So each labeling job is essentially scoped to these three components, but then you can have multiple labeling jobs, right? And one labeling job can feed into another, where, say, one labeling job is a first pass, and then the output of the first pass is sent into the second labeling job as input. And from there, you can have an audit or a review performed, right? So you can create these intricate pipelines to build your end-to-end data labeling pipelines. And kind of taking a step back, with data labeling, it's never kind of a first pass and be done type of approach. We see customers have a variety of different unique types of data labeling pipelines, where they might first do a review after the first pass and then finally an adjustment pass. Or they might subsample using some heuristic from the first pass and send maybe 5% of the data labeled in the first pass into an adjustment or verification pass. There's multiple different ways of doing this, and Ground Truth really provides you kind of the underlying primitive components to build these intricate data labeling pipelines. And so, kind of to specify that, right, you can use the API, right, to create your data labeling jobs. And you can also use the console, and the console provides nifty features to basically chain labeling jobs, etc. So you can create straightforward data labeling pipelines directly through the console itself. So moving on, I want to talk about the who will perform the labeling in the context of a labeling job. So we support two different labeling workforce options. The first is you can bring your own labelers. So we are hosting a labeling application, right? And underlying that application is Amazon Cognito. And through Amazon Cognito, you can onboard your own workers. And so these workers will have separate login credentials, and they won't have to have AWS Identity and Access Management credentials. So you can use those separate login credentials to access the labeling application and label that data, right? So if you have a team of internal labeling workers, you can essentially onboard them onto that application. And when you kick off a labeling job, the labeling tasks will be fed to those workers in the course of the labeling job. Secondly, you can use one of our data labeling vendors that are listed on the AWS marketplace. These data labeling vendors provide workforces that can work on your specific data labeling tasks. And we have a number of data labeling vendor partners here that have specific skills in labeling 3D point cloud data. And one thing to note about these vendors is that they have been pre-screened by AWS both for quality and security, and they're all SOC 2 certified. So very useful option, and it's a great way to help you scale out your workforce for especially these intensive labeling tasks that 3D point clouds require. So moving on, let's dive a bit deeper into those three labeling use cases that we discussed. And where we want to start, first of all, is talking a little bit more about those assistive labeling tools. I'll demonstrate how those assistive labeling tools work in practice when we walk through some of the worker UIs, but let's kind of understand them at a high level first. What the assistive labeling tools use is a combination of algorithms and UX techniques to make the job of labeling easier, right? To reduce the cost of labeling your data, right? And navigating a 3D scene is a very intensive effort. It's almost like navigating a gaming environment, right? And from that perspective, it can become a particularly complex and tedious task to accurately label the data in that 3D scene. And hence is why we introduce these assistive labeling tools that will help remove some of the friction and tediousness of labeling data in that 3D space. So let's talk about specifically some of those features that we built into those worker UIs. The first, snapping, is associated with drawing those 3D boxes around objects in the 3D space. So basically, when you draw the box, it might not be particularly tight fitting, and you might have to rotate the camera angle or navigate and zoom in and zoom out a lot. But we have a feature called snapping where once you draw the box around the object, Ground Truth will essentially infer a tight-fitting box around that object. The second feature is related to scenarios where you have multi-frame sequences and you're tracking an object as it moves through that multi-frame sequence. What interpolation allows you to do is essentially define the start point and the end point. So you'll draw a box in the first frame, and then you'll draw a box in the last frame, and basically ground truth will then infer the boxes in the frames in between. And basically it's using an interpolation algorithm to infer those boxes between the start and end point. Now, the third one applies to both detection and tracking, and it allows you to essentially identify and remove points that are associated with the ground. Sometimes when you're navigating a 3D space as a labeler, it's very difficult to understand or to discern points that should belong to the ground versus points that should belong to the object of interest, right? So when you use this feature uses an algorithm to understand what is ground and what is not ground, and it automatically removes ground points from labels that you have created. Now, the secondary view, again, applies to single frame detection and tracking use cases. And basically what it does is that it infers the 3D space into a 2D space, right? And so you can see a top-down view of the points, you can see a side view of the points, and you can see a front view of the points that are associated with that object. And this essentially reduces the dimensionality and allows the labeler to then focus on that specific view and precisely draw the box around the points in that context. Now, moving on, one of the biggest features that we're launching is sensor fusion. And this is also can be categorized as an assistive labeling tool. Now, sensor fusion generally is when you take the outputs from multiple sensors and fuse them together to generate a better perception of the environment, right? And so from that perspective, for autonomous vehicles especially, there's a need to use multiple sensors because you're building a perception system for a 3D road scene, right? And some of the sensors, like a video camera, will give you better contextual information as to whether the traffic light is red or green or yellow, whereas the LiDAR sensor, which is generating 3D point cloud, is going to give you better understanding of depth perception, right? And you use them in combination. Now, why this matters for labeling jobs in ground truth is that ground truth allows you to provide the outputs of both the video camera and the LiDAR device together, in a synchronized manner, and then it renders both to the labeler, right? And that's important contextual information because the labeler can see both the video camera, as you can see here, side by side with the 3D frame. So that's very helpful from a contextual standpoint, but it even goes beyond that in the sense that once you draw the box in the 3D space, that will also be projected into the 2D video frame. And then you can make some minor adjustments in the 2D video frame. And the beauty of it is then those adjustments are then going to be propagated back into the 3D space. So that's true sensor fusion. There's going to be a synchronization between the labels that you put in the 3D space and the 2D space. And that also is a tool to really help the annotator to be much more precise in the labeling that they're performing. So before we jump to the demo, let's just quickly run through each of the worker UIs for each of the use cases, right? So these are the UIs that the workers are using to perform the labeling task, right? And we'll demo a lot of the assistive labeling capabilities in this context. And that's really kind of where the heft and the major value from this feature comes in, is these assistive labeling capabilities that make the lives of your labelers so much easier. So let's play this first demo here, and we'll kind of talk through the different components. The first is the navigation, right? So you can navigate up, down, left, right, and the arrow keys here basically allow you to change the angle of the camera. Now we'll draw a bounding box in the scene, a 3D cuboid in the scene. And you'll see here in the shortcuts panel, you have a bunch of keyboard shortcuts that allow you to quickly make adjustments to this box. But specifically, we'll rotate this box first so that the arrow points the heading of the car, and then we'll tighten the box. Next, we'll use the set to ground feature, and again, this removes the ground points from the box and makes it tightly fit. And then we'll use the side views to make sure that we're only tightly encompassing the box. We can choose some of the label attributes here. We can hide and lock the label, and we can also make minute adjustments to the label here as well. So we can change the length, width, or height. We can change the rotation. We can change the label ID, and we can also change the category if necessary. Now, hiding that panel, we can delete the label as well. So next, we're going to talk about object tracking. And object tracking is where you're tracking an object across a sequence of frames. So let's dive in here. Let's play this video. And basically what you see here is that you are first going to load up all the 10 frames, and there's 10 frames in this sequence. And then the slider is basically allowing you to navigate back and forward through those frames. So now let's put a box in here. And we'll adjust the box to match the direction that the car is heading and make sure that it's tightly fitting. We're going to do a couple things here to make it tightly fitting. First, we're going to set to ground, and that's going to remove the ground points. And then we're going to fit the labels to points, and that's the snapping feature. So it tightly fits the box to the object. Now, if we navigate forward, we can see that the car is moving, but the box remains static. Now, just for the sake, let's delete the box in the previous frames. And when we navigate back, that box is no longer visible in those previous frames. Let's navigate forward in the forward frames. We see the box again. And now let's navigate to frame 6. And here, let's say we want to delete all the frames in 7 onward. So we can delete in the next frames, right? So when we navigate forward, we don't see that box anymore. Now, we still have this box in a few of the frames here. Let's just delete it in all the frames. Start from scratch. So what I want to do now is demonstrate how interpolation works, right? We want to make sure that we're capturing the car across all the frames. So let's put the box in the first frame. And let's now navigate all the way to the end frame. Here, right, you can see the car has moved forward. So now we'll move the box in that 10th frame to where the car is now. And we'll tightly fit the box. We'll do the set to ground and the snapping. And basically you get interpolation for free there, right? So the box has been interpolated in the frames in the middle. So that's object tracking, and now we'll move to semantic segmentation. Now, if you remember, semantic segmentation is basically where we are segmenting the individual points of the point cloud into pre-specified categories. So let's dive in. So you have the same navigation controls as you have in the other modalities. You have the camera angle rotations as well. And now we're going to choose a brush, right? And we're going to select a car category, and we're going to label those points as car, right? So we can also adjust the brush size. We can make it more precise or more coarse. And we can also adjust the point size, and this makes the points more or less discernible, right? And you can do the same thing for those points in the 2D sensor fuse space as well. This button here shows you essentially the line of sight for that specific video camera image. So now we'll use pedestrian category, and we can also hide categories and show specific categories. Let's reset the view here. And now let's show you how you can actually remove or unpaint some of the points. So that's semantic segmentation. Again, a lot of value delivered through the tools themselves. These are meant to make the lives of your labelers easier, and that in effect enables higher accuracy labeling. So now let's move into a demo. The demo will walk through one of our sample notebooks specifically for creating a 3D point cloud labeling job. You can see the GitHub link here for this specific notebook. I'm going to move over to SageMaker and spin up a SageMaker notebook to do this demo. So let's do that here. We're going to run this demo in a SageMaker notebook, and we'll spin up a notebook in just a moment. But the first thing I want to do is create an S3 bucket that is going to hold my input data and will also be where I output all the labels generated through the labeling job. So in S3, we're going to create a new bucket. And one thing that I want to just ensure that you do is create it in the region where you are going to run the labeling job and where you're going to run your notebook. So just make sure that there's alignment on that region. I'm going to use US West Oregon across all three things. And then, I'll point to that as we go through the notebook and go through the labeling job experience. US West Oregon, and I'm going to call this 3D point cloud live demo. And I am going to create. So voila, that is created. And basically, I am going to now go to SageMaker. Let me just remove this here. And let's go to notebook instances. Now let's create a new notebook instance. And just to confirm, we are in the Oregon region, so all systems are locked and loaded. So let's create a notebook instance here. Let's just name it demo. I'm not actually going to create it, but I'm going to show you the steps that you would want to do to complete the creation here. The biggest thing to make sure that you are doing is just make sure you create a new role here and ensure that role either has access to the specific bucket that you're using or any S3 bucket. So I'm going to create a new role here, and it's specifically going to be for any S3 bucket. So I'll create that role, and let's just create it for this sake. And you see you've created an IAM role. I have a success message there. And that's all you really need to do. And you can create this notebook instance, and it will take a few minutes to spin up. But since it's going to take a few minutes to spin up, I'm just going to use one of the existing notebook instances that I have. I'm going to use this 3D point cloud live demo notebook. And let's just open it, open Jupyter. So we'll do that. And one of the cool things here now that we've done is that notebook is actually preloaded in the SageMaker examples section. So let's navigate to the SageMaker examples section and actually, let's go to Ground Truth labeling jobs, and let's open this section. And now you will see a create 3D point cloud dash labeling dash job. So this is the one that we want to use, and we are going to use this one and create a copy. I'm going to create a copy, and boom, we are ready to rock and roll here. So the first part of this notebook, and this notebook's meant to be self-encompassed here, so you can actually start from scratch on this notebook. You don't even have to listen to the contents of this webinar. And because a lot of this content up front here that prefaces the actual demo is overview of point clouds and the type of built-in labeling tasks that we provide, as well as an overview of sensor fusion. So we're going to move to the demo section, and we are going to go ahead and start the demo portion here. Before we get to the demo, we do need to do one quick permissions item with respect to the S3 folder that we created. So I am going to navigate back to S3 just for a moment, and we are going to open up that specific bucket that we created. And it's live demoing. You can see this was the one in US West Oregon. So we're going to open up that bucket, and we are going to go to permissions, and we are going to go to course configuration. We're going to go back here. We're just going to copy and paste this as is, and we are going to dump that into this course configuration, and we are going to save. And now we are ready to go with that prerequisite. So let's go back to the 3D point cloud notebook, and let's start running the first cell here. So this runs, and you'll see when each cell completes running, it will show a number here. So let's run the next cell, and now here is where we actually need to add some of the information that we have from S3. So we need to first put in the bucket that we created. So that was 3D point cloud dash live dash demo. And this is just any prefix, valid S3 prefix. This is basically where your output data will go. So let's just call it output. And let's run this cell, and let's run the next cell. All right, so that kind of sets things up for us. And the first thing that we're going to do now is we are going to download the data that we're going to use as part of this demo. So we provide you a small data set, and it's as simply as running this cell to download that data set into that S3 bucket that you created. That's going to take a minute. Let's just let it run. And once that's completed, we can move on to essentially the creation of the input manifest files. And so our labeling job takes an input manifest file to essentially points to the data, and then the API will use that input manifest file then to parse through all the data and access it in S3. So here you can see the cell ran correctly, so now all the data has been downloaded to your S3 bucket. So let's see what that looks like. We will move on here, and basically you'll see now in your bucket that we created, right, you have an artifacts folder, and within artifacts you have gt-point cloud demos folder, and here are the folder prefixes that we created. So there's frames, so this is actual raw data, and then config files, as well as manifests that you'll be able to use to feed into the labeling job. So let's continue moving through this. And before we look at what the manifest looks like, what we need to call out is if we go back to the presentation, we discussed the notion between a single frame versus a sequence, right? So you're going to have a different manifest type for single frames, and you're going to have a different manifest type for a sequence of frames, right? And again, just to review, when you are dealing with single frame tasks, right, that is for object detection, so you'll detect objects in a single frame, or you'll semantically segment a single frame. Where sequence of frames become important is when you're tracking objects across frames in kind of a temporal fashion, right? So let's run through these cells quickly. So this sets things up, and then here we go. We can see how a single frame manifest file looks like. So this is one line of the manifest, so this corresponds to one frame. And you see here the txt file for the point cloud, right? So the point cloud, if you remember, these are actually the point coordinates, the XYZ coordinates of the points in the point cloud, and they're encompassed in that txt file. And then you have additional information for that specific frame, right? So the ego vehicle is the vehicle where the sensor is mounted. And dash pose means is the information regarding the heading, so the direction that the vehicle and sensor is moving and the position of that sensor. In addition, if you scroll down here, right, you can see the Unix timestamp when that frame was taken, and you can see where that frame is living in S3, so the S3 prefix. Now, if you remember, we talked about sensor fusion, where we're synchronizing output from video cameras with the output from the LiDAR sensor, right? So here is one image that has been synchronized, right? So for that image, here is the image path in S3. And then you also have pose information for that sensor, right, for the video camera, and that is this heading information and the position information. You also have the intrinsic matrix that's captured right here, and this is used to essentially make those transformations from the 2D space to the 3D space. You also have some metadata for the camera. Now, we won't go in depth here, but these parameters here are for correcting distortion effects in the camera, right? So it's a very useful feature to essentially correct for those distortion effects, and you can input those parameters here. And you also see the timestamp, and you can see that this timestamp actually matches with the timestamp for the 3D frame. So moving on, let's look at what a single line in the point cloud file looks like, right? So point clouds can range from anywhere from 50,000 to 250,000 points, and in some cases, some point clouds have millions of points, right? But typically, you're going to see point clouds in the 250,000 ballpark, right? But each point has these four parameters associated with them. The first three are XYZ coordinates, and then you have the pixel intensity here, right? So that's what a single line in that point cloud file looks like. So with that, we've kind of covered end to end what an input manifest looks like for single frame tasks. Now let's look at a sequence of frames input manifest. So it's a multi-frame sequence, right? So let's move through this. And let's see what one line of the input manifest looks like. So if you remember above, what we had was a single frame, the txt, right? And that is the actual point cloud file. Here, what you have actually is a JSON file, because the JSON is essentially a pointer to the underlying frames that constitute the sequence, right? So let's unpack the JSON file here. So here we'll now see what the JSON file looks like. And now this basically, you'll see a lot of the same information that you saw for the single frame, but there's multiple frames in this context. So let's look at it. So this is the first frame, right? So it's 0.txt. You similarly have the heading and position for the ego vehicle pose. You have the camera that is synchronized with that 3D frame. You have the timestamps, etc. Now here you see is the boundary line for the next frame. So you can see 1.txt. Similarly, you have the heading and position information for that frame, and you have the images that are calibrated. And that goes on and on. I believe there's 10 frames in this sequence. So you see frame 2.txt, and that basically continues to the end of the sequence. So moving on here, now that we've talked about the input manifest, and again, this points to the data in S3, and this is what our API consumes, we can talk about setting up the labeling job itself. And the first thing that we're going to do is we are going to specify the task type here, right? So we've actually chosen object tracking. We are going to do 3D point cloud object tracking. So let's run these cells here. And the next bits, we're going to kind of just provide the configuration, right? For setting up the task, as well as setting up the job details. So quickly, we will go through here. This is basically a map for all the Amazon resource names, so ARNs for the specific UIs. And just to kind of a recap quickly, when we talk about a built-in workflow, there's 3 components. There is the UI ARN, and so you can see one type of UI ARN for 3D point cloud object detection, object tracking, and semantic segmentation. You also see UI ARNs for each of the adjustment workflows, right? So this is when you take the output of a previous job and feed it into this UI, and you allow the annotator to adjust the labels that were drawn in that label, right? So basically, you have an adjustment UI for each one, right? So you have adjustment object detection, adjustment object tracking, and adjustment semantic segmentation. So this is the map. We are obviously interested. We're going to be running the 3D point cloud object tracking. So let's run this cell and move on. Next, we also have a map for the S3 URI, right? So this is the manifest. The manifest is going to be specific depending on the task that we're doing, right? So for object detection, we're going to use the single frame manifest. For the object tracking, we're going to use the sequence manifest. And the adjustment manifests actually have existing labels in them. So you can use this notebook to run those scenarios where you're preloading a label for adjustment also. So pretty nifty, pretty useful notebook from that perspective. So let's move on. Let's talk about the label category configuration file. Now, this is the file that's actually going to define the task. So, you might have different label categories that you want the labeler to pay attention to, right? So you might care about motorcycles and vehicles, where another customer might care about ambulances and buses, right? So that label category file is defined by you, and let's quickly walk through that. So here we have a notion of attributes also. So these are not the label categories. These are associated with labels. So you will have a label which is vehicle, and then an attribute is, for example, whether the vehicle is occluded or not occluded, right? So this is a global attribute. So this actually will apply to all of the label categories that we define. So for any label category, whether it's pedestrian or car or bus, you can mark whether there's occlusion, whether there's partial or full occlusion, right? And this is an optional attribute. So now let's move to the first of the labels. Here the label name is the label is car, right? And we've also specified an attribute, right? So the attribute name is car, it's type of car, right? And then you can specify one of these enums, which is SUV or sedan. Right, so let's look at the next one. You have bus, and we have also set up an attribute, which is the size, large, medium, small. So this is the label category file, and this is something that you do need to specify when creating the labeling job. So let's move through the next step here, right? We will, the label category files are also, we've defined one per task type, right? So we'll set that up, and then we'll continue on here. The next piece is that we want to set up the human task configuration. And one of the most important things that we need to do here is actually provide the ARM for your work team. So let's go back to SageMaker quickly here, and let's go to your workforces. And basically, we will go to private. And we will now choose this ARM, right? So I already have one created here. I can show you the work team. It just consists of 2 workers, but this is the ARM for that work team. And I am, sorry, just going to enter that ARM here. And we're going to move on. And let's move on. So here, let's just quickly add some of the task parameters. So this is a task description. So road, scene, labeling. We'll add a task title here. So please label the objects in the road scene. And let's just name this 3D point cloud. live demo. And let's run this. You can see we're setting up the human task config. This is going to pull in items like basically the annotation consolidation lambda. So this is the post-processing lambda. We also have the pre-processing lambda. We have the work team ARN that we defined up there. And we insert the task title, task keywords, task description, and the task time, time limit in seconds, right? And the task availability lifetime in seconds. So these are just the general configuration parameters for the labeling job here. So let's run that. Let's print here. So now let's set up the labeling job request. So let's run through this. Now let's kick off the labeling job. You can check the status here. And now you will actually see this labeling job propagate into your queue. There is some pre-processing time for the 3D frames, right? So it might take a few minutes for it to show. So if we come back to the screen where we have the labeling workforces, you can copy the sign-in portal. And the 3D point cloud does work best in your Chrome browser. So we will open up Chrome and we will paste that link. I'm already logged in here. And so we're going to log out. And we're going to sign in, and you're going to see the job here once the post-processing is done. So I'm just going to reload the page here up, and there we go. So here's the labeling job, right? And you can start working and check out this labeling job. It's going to load up the task, and you'll see the labeling UI here. And with that, we're done. So that completes the demo. Let's just quickly go back to the slide deck here. Thank you. Let's open it up to some questions.